Hi, my name is Kusha and my presentation is on the topic type of sources in electric circuits. And there are two kind of sources, mainly voltage and current sources. But the categories of sources are independent sources and dependent sources, which we further discuss in the presentation. First one is independent source. These type of sources does not depend on any other value like voltage or current in the circuit. The symbol are shown voltage source and current source. These sources are also divided into two categories. Voltage source is divided into two categories, ideal voltage source and practical voltage source. Same for current source. Now understand the independent source by an circuit diagram. As we can see in the circuit, R, C and L are connected with voltage source V. If we change the value of R, C, L to 2R, 2C, 2L, then the value of voltage is same for all the cases. So we can say it is independent on the circuit connected to it. Next one is dependent sources. These sources output value depend on change in voltage or current in some part of circuit. The as shown in presentation, the dependent voltage source sign is like that, and dependent current source is like that. Next one, dependent source, we can understand it by an example. As we can see in the circuit, if there is Ix current flowing through 2 omega resistor, the voltage change with current with change in value of current. So we can say that in part of 2 omega resistor, the voltage value changing with respect to change in input current Ix. So it is a type of current control voltage source. Dependent sources are of 4 categories. Number one is current control voltage source, CCVS. Second one is voltage control voltage source, VCCS. Third one is current control current source, CCCS. And the last one is voltage control current source, VCCS. Now discuss one by one all of them. First one is current control voltage source. As its name suggests, current is controlling the value of voltage. This can be understand as in figure. If we change in the value of I in, the value of I out is the value of V out is changing with respect to I in, that is input current. The relation is V out equal to R I in. Here R is coefficient of voltage source and its unit is volt per ampere. Sometimes it is also known as trans resistance. Now take an practical example of CCVS, which is op-amp as transconductance. As shown in figure, we can see by the circuit, V naught value is depend on input current II. As II is changing, the value of output voltage V naught is changing. So the output voltage is depend on current input current. Next one is current source, CCCS. In this, current is controlling the value of the current source. This can be shown by a relation I out equal to alpha I in. Here the alpha is proportionality constant, or also called current transfer ratio, or it is unitless parameter. Now take an practical example, BJT, which is also called bipolar junction transistor. Here the base current IB is controlling the value of collector current IC. So it is an example of CCCS. Next is voltage control voltage source. Here as shown in figure, voltage V out is depend on input voltage V in. So this can be shown by relation V out equal to mu times V in. Here mu is voltage transfer ratio and V in is input voltage which can control the output voltage. The mu is unitless quantity here. Now take a practical example. Op-amp as non-inverting or inverting configuration. It is an example of VCCS. Here we can see V0 is depend on V1. As we change the value of V1, the value of V0 change by relation minus 2R upon R into V1 equal to V0. Once we adjust the gain of the op-amp, the Vout is depend on input voltage V1. The last category of dependent source is VCCS, voltage control current source. Here the voltage is controlling element which control the output of current of this current source. The relation can be shown by I out equal to G V in. Here V in is the input voltage, I out the output current. G is the coefficient of current source, or its unit is A by V, ampere by volt, or which is also unit of conductance. G is also called transconductance. The practical example of VCCS is MOSFET. In MOSFET, as we change the gate voltage, the drain current change accordingly. Relation is ID is proportional to VG square. That's all. Thanks.